All right, this is the last page here of our review for the test. We were asked to sum these two up here. So 18 is a sigma notation. We're going from 4 to 7 here. So in other words, we're just going to go ahead and put 4 in, and that'll give us -1 to the 5th power. So -1 times 4 minus 2 factorial. So that's 2 factorial, or 2 over, put 4 in, 2 to the 3rd power, which is 8. Okay, so that's when n equals 4. Okay, then I'm going to put 5 in. If I put 5 in, I'm going to get a +1 times 3 factorial, so that's 6, over 2 to the 4th power, which is 16. Okay, that's when n equals 5. If I put 6 in, I'm going to get a -4 factorial, which is 24, over 2 to the 5th power, which is 32. That's n equals 6. And then n equals 7. I put that in, I'm going to get 5 factorial over that. All right, so this is what I'm dealing. These are the 4 terms, 4, 5, 6, 7, and we want to add them together. And if you were going to do this, say, without a calculator, probably the best thing to do is get a common denominator, which would probably be 64. This needs to get multiplied by 2. This would get multiplied by 4. This would get multiplied by 8. So now I have, all of these are 64s now. I got -16 plus 24, that's 8. 8 minus 48 is -40. -40 plus 120 is 80 over 64, which is 10 over 8, which is 5/4. I get 1.25 when I work it out. All right. And so again, you got to do them individually. If you don't have a calculator, one by one, get a common denominator, and then put them together to get to there. For 19, we're not going to do that. It's an infinite sum. What we need to do on 19 is see a pattern forming. So on the top, I see that I'm multiplying by 2 to get from term to term, and on the bottom, I say I multiply by 3 to get from term to term. So that's my common ratio. R is 2/3, and I see that the first term is 10/3. So since this is an infinite geometric sum, I know that this is going to equal first term over 1 minus common ratio, which is 10/3 over 1/3, and if I flip that and multiply, I'll get 10. So that's not too bad. Then we get this infinite g of x is this infinite power sum. We're going to deal with this a lot more in the second part of chapter 9. But what it's asked is to use the first 4 terms to approximate g of 1. In other words, put 1 in for x and use the first 4 terms to get an approximation. So if we put 1 in there, we're going to get 1 minus 1/2 plus 1 over 4 factorial, which is 24, minus 1 over 6 factorial, which is 720. Okay, so again, if I kind of try to work this out by hand, I'm going to get that plus 24 to 720 is times 30, it looks like. All right, minus 1. All right, so that's a little bit of work, but now I got 720 minus 360, that's 360, plus 30 more is 390, minus 1 is 380, I'm sorry, 389 over 720. So you can do it by hand. Obviously, a calculator would be a little quicker, but that's the idea. We're putting 1 in for x, and then we're adding those terms. If it had said g of 2, we'd put 2 in for x, all right, and then we would do the same thing just with now 2 squared, 2 to the 4th, 2 to the 6th. Now this says, why can we be sure that this approximation is within 1/40,000th of the correct answer? So here's the deal. We know that the difference between g of 1, whatever g of 1 actually equals, which would be this all the way out, forever and ever with 1 in for x. If you did that forever and ever and ever, that would be g of 1. Now, we're not going to be able to find that. That's an infinite sum. That's incredibly difficult. That's why we're trying to approximate it. So the difference between the actual answer and our approximation, which was 389, 720, that's just a guess, right? That's our approximation. We think it's close to that. The difference between them, and we'll take the absolute value, so that if g of 1 happens to be smaller than this, it'll work it out. We're just looking for the difference between them. The difference between them will be less than or equal to the very next term that we chose not to use. So the next term we chose not to use would have been x to the 8th over 8 factorial. It doesn't matter if it's positive or negative because we're using absolute value anyway. We just want to know what that is. And so that, if I were to put 1, since we were doing g of 1, if we put that in for x, we get 1 to the 8th, or 1 over 8 factorial. All right, and 1 over 8 factorial, let's see, 720 times 7 is 5040. If I multiply that by 8, 2, 3, all right, is 40,320. Okay, so the next term that this again was the next term that we did not use, the first neglected term, or however you want to say it. And I did 8 factorial, and I got 40,320, and that is less than 40,000, which was the tolerance that they were asking for. So this approximation here, we know, is within 1/40,320th of the right answer. Maybe even better than that, but we can say it's no worse than that for sure.